Welcome back students to this new module. In this module, we are going to learn the board's problems for photoelectric equation. And in that case, the very first problem that I have, it says that the maximum velocities of electrons emitted by a metal surface are given by 2v and 1v when it is irradiated with a light of wavelength which is given by 350 nanometer and 540 nanometer respectively. They are asking us to calculate the work function of the metal. So let us write down the given data. The first maximum velocity is given by 2v. The second maximum velocity is given by 1v. Can I say the first wavelength is 350 nanometer? The second wavelength is 540 nanometer. Now 350 nanometer and 540 nanometer can be respectively written as 3.5 into 10 to the power minus 7 meter and 5.4 into 10 to the power minus 7 meter, since meter will be the SI unit. Now what do we need to find out? We need to find out the work function. Which formula are we going to use? Yes students, you guessed it right. It is the Einstein's photoelectric equation, which is given by E is equal to W naught plus Ke max. Now with the help of this, we'll go ahead to solve the problem. Now this is the given data which is there with us. While solving the problem, let us consider case 1. We know that E is equal to W naught plus Ke max. But can I say I can write energy as hc by lambda? And since this is case 1, I'll write it as hc by lambda 1, which is equal to W naught plus Ke max 1. Now Ke max 1 can be written as half m V max 1 the whole square. But we know that V max 1 is twice the velocity. So can I say in V max 1's place, we will have 2V which will be substituted. So the same equation now becomes hc by lambda 1, which is equal to W naught plus half m 2V the whole square. On solving this equation, we get the final answer as hc by lambda 1, which is equal to W naught plus 2mv square. We mark this equation as equation number 1. For case 2, now you must be wondering that we have the same parent equation, that is E is equal to W naught plus Ke max. So now my direct product equation, final equation will be hc by lambda 2, which is equal to W naught plus half m V max 2 the whole square. But we know that V max 2 is actually V. Substituting that V in the place of V max 2, we get the final answer as hc by lambda 2, which comes out to be W naught plus half mv square. Now when we have this equation, I mark this equation as equation number 2. Can I say now to find out the work function, what we are doing is we are subtracting equation 1 and 2. On subtracting equation 1 and 2, we get hc in bracket 1 by lambda 1 minus 1 by lambda 2. That comes out to be 3 by 2 mv square. So can I say alone v square will come out to be 2 hc by 3m in bracket 1 upon lambda 1 minus 1 upon lambda 2. Now students, in this case, we know the value of h, c, m, lambda 1 and lambda 2. So substituting all the values in this, we get the final answer of v square as 0.146 into 10 to the power minus 12. But students, solving for v square wasn't our intention. Now we need to substitute v square in equation 1. We knew that equation 1 was hc by lambda 1, which is equal to W naught plus 2mv square. Now I know 2, I know m, I know v square, I know h, I know c, I know lambda 1. I need to find out work function. Students, now can I solve it? Yes. Now I can very easily solve this equation. So can I say this is how I'll substitute the value, and W naught alone will be 5.68 minus 2.65 into 10 to the power minus 19 joule after solving, and the final answer will come out to be 3.03 into 10 to the power minus 19 joule. Students, the solving part you should try it on your own and you will be easily able to get to this answer. Now, this is the work function that we have removed from the first problem. In the next problem, we have a problem which is not concentrating on the work function. It is asking us to find the value of h. Now what this problem is all about? It says that there is a light having a frequency 2.2 into 10 to the power 15 Hertz. Now this can be stopped by a retarding potential of 6.6 volt. So can I say I've been given by frequency 1 and stopping potential 1. There is another light having frequency 4.6 into 10 to the power 15 Hertz with a reverse potential, that means again the retarding potential or the stopping potential, as 16.5 volt. And then they are asking us to find out H. So let us write down the given data, that is nu1 and Vs1, which is 2.2 into 10 to the power 15 Hertz, and Vs1 is 6.6 volt. I have frequency 2 and the stopping potential 2. What do I need to find out? I need to find out the value of H. The formula that we are going to use is obviously E is equal to W0 plus Ke max. Moving ahead to solve the problem, we have the given data with us. We know that energy is equal to W0 plus Ke max, but we know E is H nu, so I'll substitute H nu1 will be equal to W0 plus EVS1 and H nu2, which is equal to W0 plus EVS2. Now you must be wondering, how did that EVS came from? Students, remember, kinetic energy is equal to E into Vs, and that result we are using over here. So on the basis of these two equations, let us subtract both the equation and we'll have H nu2 minus H nu1, which will be equal to W0 plus EVS2 minus W0 plus EVS1. Can I say H will be common? In bracket, if I take nu1 minus nu2, so over there W0 and W0 will get cancelled, and E in bracket Vs1 minus Vs2. Solving for H, I can write H is equal to E into Vs2 minus Vs1 divided by nu2 minus nu1. On substituting the values and solving for the H, we get the final answer of H as 6.6 into 10 to the power minus 34 joule seconds. So students, with the help of this module, we learned how to solve the problems of electrons and photons which are related to photoelectric effect. Thank you.